you know, when you're talking millimeters per year, it's sort of hard to get a perspective on what that really means, right? But one way to think about it is that just since the 1938 hurricane, sea level has already risen a foot. And if we look back to the 1635 hurricane, sea level's already risen 2 feet. So now we're starting to get to scales that we can actually think about. And if some of these projections are right, in our lifetimes, we might actually see another foot or two of sea level rise. And so that sort of puts it at a scale that, you know, at least most of us can appreciate, rather than thinking of it in terms of millimeters per year. And I'm happy to take any questions. And there's a couple websites here where you can get to some of our publications and other materials. So, yeah.
You mentioned that we were going to lose our salt marshes and presumably our dunes was currently protected from forming. How far back are we going to have to adapt to remove our coastal infrastructure if we lose our natural barriers?
Well, that's sort of out of my, it's above my pay grade. I mean, that's going to vary from location to location. In part, you know, I showed that earlier plot where some places are much more exposed to waves. Some are exposed to surges. So it's going to be sort of a local determination in terms of what your exposure is and what your resources are and whether you're capable of even moving them. So I leave that to you guys at some level. I mean, that's sort of, I'm certainly willing to help and provide some perspective and what the probabilities of various events might be. But the actual planning and moving of resources is something I guess we'll have to all work together on. So, yeah. Oh, sorry.
I just want to make sure everybody can hear the questions. If you have your head, go ahead.
Jeff. Hi. I'm just curious. You talked about the difference. You said you didn't really know what the answer was, but you talked about the difference in the frequency of major hurricanes might have to do with the different rates of cooling or warming of
what matters
the Earth
is that
versus
atmosphere.
The atmosphere. And so my question is, does do the climate models take that into account? Do they give you the relative difference of warming? Okay.
They do. Yep.
Ted, could you introduce yourself when you're asking a question, please?
I'm Ted Gale. A question concerning the sun. Putting aside and taking out of the equation our atmosphere, which is another whole issue, has there been computer modeling relative to the distance between the sun and the Earth sufficient that we either know or don't know whether or not a variation in distance might impact water temperature?
We actually know that really well, and that's all included in the model in terms of the geometry between us and the sun. What's less well understood, although we do have some data for it, is actually the amount of energy the sun's emitting isn't constant through time. And so that solar variability actually has an impact on the climate as well. And that's included in those climate model runs as well. So there's this sort of natural variability in the output of the sun, and it's also you know, things like volcanism can impact the amount of that radiation that's actually getting to us. And so these climate models are also, at least when we're thinking of it in the paleo sense, we're going back in time, we're taking into account that solar variability as well as things like volcanism that might impact the amount of radiation that actually gets to us here on the surface.
Part B.
Yeah.
And that is, we had a fantastic lecture on Monday by Dr. Susan Humphreys down at the library concerning her work over the last 30 years on Alvin. And she discussed the bulk of her scientific endeavor has been the study of these, I'm going to call them sea vents, which are nothing but events caused by undersea volcanoes, which are heating up seawater to about 700 degrees. I don't know if there's 1 million of these, 10 of these, or 1 billion of these, but has there been modeling to determine what, if any, impact those events have on ocean temperatures? And is it linear, or do we know?
I don't know if we know. I mean, there's been a fairly small number of them studied in any great detail. They occur in almost all the ocean basins along these plate boundaries where these spreading ridges are occurring. that being said, they're fairly localized. I mean, it's a big local effect, obviously, when you're superheating this water. But on the global scale, I haven't actually looked at the numbers. My suspicion would be that it's a fairly small contribution to the overall heat budget of the ocean, would be my guess. But we can call Susan and see what she thinks.
Jerry Patamas, Town of Falmouth. I've had two different answers to the same question.
Well, maybe I can give you a third.
Okay. So, I would assume the sea level should be the same all over if water seeks its level ground. But I've had other people tell me that the sea level in Florida could be different from up here versus Europe. And maybe there are minor changes, but is there anything statistically important about that?
Hopefully Jerry will be here later this afternoon and he will hammer this point. But the reality is sea level is always local. And the reason it's local is because the land is doing things, as well as the ocean. So you've got the ocean change, and it's not as simple as a bathtub sort of filling up. But there's local land changes that occur. And for example, if you go to Maine, the sea level rise rates are half a millimeter or even a millimeter slower than they are here. And the reason that is because we're actually slightly subsiding relative to Maine, and that's a leftover influence of the ice sheet that was here. So the ice sheet was sitting on top of us and most of Canada. It actually depressed the mantle material underneath the crust out to the edge of the ice sheet. And then you took the ice sheet away, that mantle material is still trying to get back to Canada, basically. It's sort of this long time scale response. And so we're actually subsiding slightly relative to Maine. And the Hudson Bay is actually rebounding. It's actually elevating. Sea level isn't rising there, it's actually falling. Another thing that actually Jerry Mitrovica, who will hopefully be here later this afternoon, sort of pioneered is the ice itself in Greenland and Antarctica. There's so much of it, they actually have their own gravitational attraction. They're big enough that they're actually pulling water towards them. And when they melt, they lose some of that gravitational attraction and water moves away from them. And that actually causes a pretty big geographic difference in sea level rise patterns. Another thing that happens that can cause some geographic variability in sea level rise is changing ocean currents. And so where you're piling up water on the margins actually can have an impact on sea level rise. So if you look at the tide gauges from Florida, for example, most of them are pretty modest. They're about 1.5 millimeters, and whereas we're seeing 2.6, 2.8, and so it's almost a millimeter per year difference there. When you get up to these really large rates, though, so we're talking sort of 0.5 millimeter, a millimeter per year difference between us and Maine or us and Florida. But when you get up to 10 or 20 millimeters per year globally, we're all in trouble, basically. Jerry, who might show you this later if he's able to make it, has done some experiments where he just gets rid of the entire Greenland ice sheet and sees what happens. And it turns out if you do that, there's a big global rise in sea level, but because of that gravitational attraction is lost, we actually see a fall in sea level here. Even though globally there's 7 meters or something of sea level rise, most of that gets funneled towards the southern hemisphere because of this gravity. I mean, that's an extreme. We're not going to lose the Greenland ice sheet tomorrow, hopefully. But if we did, that would be sort of the response. So there is a great deal of geographic variability in sea level rise.
Joanne.
Joanne Taylor. I actually have two questions, and I have a mini response to that question. We've looked at this on the Martha's Vineyard, our relation to eustatic sea level rise, and we've found there's a sea level gauge in Woods Hole, there's one in Nantucket.
Mm-hmm.
So we figured that ours, there's none on the Vineyard, but we figured that since these recording devices have been in place, we, on the Vineyard, have experienced about a 40% increase in sea level rise over what has been eustatic sea level rise. So doesn't mean that that's going to be the same for the next 200 years or so, but that sort of gives us a gauge of how much faster sea level rise may be expected here. Recently, it has been 40% greater an increase than worldwide sea level rise. My two questions, one is about the 1635 hurricane. I know about that same time, a few years before or after, there was also a major earthquake in our area, and there was also the mini ice age where in Europe and here temperatures were much lower than usual. So I wonder if there are, no, there are obviously other factors besides sea level rise that create these conditions of possibly greater storms, besides temperature rise. So I wonder if that can all be assimilated into some kind of a model. For instance, if we start having earthquakes, then we know we're going into one of those cycles again. And the other thing is that
I guess, can you, how do we connect the earthquakes to the climate necessarily? That's what you lost me there.
Right. Is that just a coincidence, or might these same records also show if there has been earthquakes at the same time as these major storm events?
Yeah, some people have actually postulated that a hurricane can cause an earthquake.
Oh, okay. So it would be after.
And there's sort of not very good evidence to support it right now, but it's at least a hypothesis that's out there.
Well, it's just an interesting idea.
Yeah.
And then also we've always assumed, maybe anecdotally, that the major hurricanes that hit New England, like the 1938, they actually originate off the coast of Africa, and that the hurricanes that originate in the tropics tend to go into the Gulf and not bother us. And that it seems to be a little bit different in your model. So.
I mean, many of the storms are sort of Cape Verde type storms. For example, Gloria was a Cape Verde storm. 1938 was a Cape Verde storm. So these are storms that are forming pretty close to Africa, traversing the entire tropical North Atlantic and eventually sort of recurving up and hitting us. But surprisingly, I was actually surprised by the numbers. I think it's about 40 or 50% of the storms that actually impact us are storms that sort of form off of the Bahamas. Bob, for example, Bob wasn't a Cape Verde storm. Bob formed over the Bahamas and then shot right up the eastern seaboard. And so it's sort of a mixed bag. We are getting quite a few of these Cape Verde storms, but there are a lot of storms that are forming sort of in the Bahamas region that just translate right up the eastern seaboard. And obviously we're sticking out, the Gulf Stream coming up and right off our coast. So we're sort of an easy target. Did you have a second question?
Yes, that was it.
That was it. Okay.
Thank you.
Good. I did see a hand right here.
Yeah.
You mentioned cool water. What was present? Where is it?
Where's
I mean, the cool water that you mentioned, it couldn't be in Buzzards Bay. Is it Maine or?
at the little ice age transition there, the
Yeah.
cold water. We don't actually have any local measurements of sea surface temperature. We have a couple from one from off of Bermuda, one from off the Bahamas, and another off of Puerto Rico. So they're more tropical, and those are all sort of pointing towards cooler sea surface temperatures, which initially puzzled us. We're seeing this, nothing local though. Yeah.
Hi, Janet Friedman from Rhode Island, and I was wondering how much research has been done on looking at the increase in extratropicals?
Not as much, and we're sort of wrestling with that and sort of how to deal with that. We've just gotten to the point now where we can do the tropical cyclone modeling because there's this separate model that we can embed in the GCMs. The global climate models that the IPCC is using can't generate a tropical cyclone. They don't have the detail necessary to actually have a tropical cyclone form and propagate through the atmosphere. So the only way we've been able to sort of get at this question is to take Kerry's model, more simplistic model, and sort of embed it inside these global climate models. The global climate models do a bit better job with the extratropical storms, but they're all over the place in terms of whether we see an increase or decrease. There's sort of no clear trend at this point. And obviously, we're talking about storms here that might occur once or twice a decade. We get nor'easters every year, and if that change in frequency, they may not be quite the magnitude of these storms, but if those storms are increasing or decreasing in frequency, it might have a pretty big impact. But it's a question we just don't have an answer for really at the moment.
We'll stop the questions for Jeff, and I didn't see any more hands up right away. So can you join me in just thanking Jeff for a really good answer?